Alright, let's take a look at an application where we can actually utilize the derivative. So in this question, the owner of a local hair salon is planning to raise the price for a haircut and a blow dry. The current rate is $30 for the service, with the salon averaging 550 clients a month. A survey indicates that the salon will lose 5 clients every incremental price increase of $2.50. Write a revenue function and solve for r prime of x is equal to 0. What is the significance of this value? Okay, so when we're looking at revenue, we need to first define what revenue is. So the revenue function r of x is going to be equal to the unit price times the quantity function. Now the unit price can also be considered the demand function, right? So for the unit price or the demand function, I'm going to call this guy P of x. For the quantity function, I'm going to call this guy Q of x. And I'm going to let each of these guys be relative. X is basically an incremental increase. Okay, so x is an incremental increase. Okay, and we'll kind of define what that means. So we can understand that the revenue function here is equal to the unit price, which is basically $30 originally. And at $30 we can see that we have 550 clients, but each time we increase the price by $2.50, so 250x, and x is the number of increments, we're basically going to lose 5 clients. Okay, so you can understand how x acts as an increment, that it basically will change the quantity sold and the unit price itself. Okay, now this basically looks like a product of two functions, right? So you can see that r of x is basically equal to p of x times q of x, and we want to figure out r prime of 0. Okay, sorry, r prime of x is equal to 0. Okay, and we're going to ask ourselves, what does that really mean, right? So let's first figure out what r prime of x is. Okay, so r prime of x, if we use the derivative, right? If we look at the derivative, we can see here that we get derivative. I'm going to be utilizing the product rule, so I'm going to do the derivative of the factor on the left, 30 plus 2.5x times 550 minus 5x. Whoops. Plus the derivative of 550 minus 5x times 30 plus 2.5x. And if I crunch this out, you can see that you get 2.5 times 550 minus 5x minus 5, 30 plus 2.5x. Okay, so you can see that r prime of x here is, if you punch all of this out, you'll get 1375 minus 2.5 times 5, 12.5x minus 150 minus 12.5x again. Okay, so r prime of x here is basically equal to, and if I combine this together, I get 1375 minus 150, 1225 minus 25x. Okay, then what I want to do here, according to the question, I'm going to let r prime of x equal 0. And there's going to be significance associated with this. I'm just going to do that out here. So you get 1225 minus 25x is equal to 0. I'm going to move the 1225 here, so negative 25x is equal to negative 1225. If I divide by negative 25 to both sides, x is equal to 49. Okay, so this tells us that x is equal to 49. Okay, well, what does that x is equal to 49 mean? Well, what we want to do here, I'm just going to make some space, so I'm just going to erase this portion out. So x equaling 49 is going to be the incremental increase. Okay, so the incremental increase if we look at a revenue function, I'm going to plug in R49, and we're going to look at what happens to the unit price, and we're going to look at what happens to the quantity. Okay, so this is going to give us P of 49 times Q of 49. Okay, now P of 49, your demand function, is going to basically look like 30 plus 2.50 times 49. And now the cost per service, 30 plus 2.5 times 49, is $152.50. Okay? Then we're also going to look at Q of 49, and we're going to get 550 minus 5 times 49. And we're actually going to get 305. So this tells us that at the price of our service is going to be $152.50, and that we're going to have 305 clients. So that's a significant decrease in the number of clientele. And we can see that the total revenue here is P of 49 times Q of 49, which is equal to 46,512.5. Okay, now this is basically $46,512.50, and this is actually going to be a maximum revenue. Okay, we technically found the maximum potential revenue that we can possibly make, and we did this by setting the first derivative function to 0, and this actually alludes to optimization, which we will discuss in future lessons.